This video will provide you information about the Applied Quaternary Geology track at the University of Freiburg. If you are wondering about what quaternary geology is or want an overview of the master's program, then check out the other videos on the channel. The aim of this video is to give you a more detailed overview of the key modules and what you can expect to learn. The Applied Quaternary program can be very broad, but is designed to give us the skills and knowledge for a successful future in the geological world, be that in industry or in academia. There are 6 key modules in the program, which we can see here. Sedimentary geology, quaternary research, and geohazard geology are fundamental modules. They give us the core knowledge for processes, research methods, and situations in quaternary geology. Engineering geology, earth management, and hydrogeology teach the applied aspects of the program. We can use the knowledge learned from the fundamental modules and apply it to real-life situations in these modules. So, what can you expect to learn in these modules? Let's start with the fundamentals.
We study a lot of environments. For example, we have fluvial environments, we have glacial environments, and we have aeolian environments, and we get to take a closer look at all of these environments in detail, like in the field section part.
Moreover, we have this practical part where we can apply all this theoretical part of the lectures into field and lab work. One example of this are the loess outcrops in the Upper Rhine Valley or the glacial setting in the Black Forest. Also, we took some samples in these places, and we used these samples to do some lab experiments, lab projects, where we get to know the grain size, the carbon content of the sediment, and with all this information, we gather all this information with all the theoretical part, and we can reconstruct the history of these environments. That's why this course is pretty important and pretty interesting for a geology student.
Firstly, the module has introduced the students to the main proxies of the quaternary research, which is sediments, wood, pollen, and etc. Secondly, it will introduce the students to the different dating methods like luminescence dating, radiocarbon, and cosmogenic nuclear dating, etc. And finally, it will help us to give an overview of the ability to understand the different environmental and climatic reconstruction during the quaternary. So that's it.
You are getting an example like some ancient riverbeds in Africa or mountain ranges or something, and then you really have to think about how could you date this area, which proxies can you use, which archives are there to use, and then how much money you could spend on all that, is it usable, and then really have to think about how to date the area.
Geohazards is a relatively new module in the program. It focuses upon reconstructing geohazards. You'll look at case studies and learn how these situations could be better managed. There are other modules in the program where you can further deepen this knowledge, such as mass movements, earthquakes and tsunamis, and volcanic hazards. The annual field trip to the Alps will also involve looking at geohazards such as mass movements in the area.
We are here in the Outer Oets Valley, and in the background you can see the Köfels rock slide. The Köfels rock slide is the second largest mass movement of this kind in the Alps. And we are here to discuss the different methods and techniques to date and to investigate these landslides and also other types of mass movements like rock slides, rock falls, and debris flows, for example.
Moving on to the applied aspects.
Engineering geology gives you a basic idea how to solve geotechnical problems. For example, you learn how to plan reservoirs, how to build construction pits, and how to increase slope stability. But the module has also a practical part. You will work in the laboratory and you will get your own topic on a geotechnical problem that you can present the class.
Part of the engineering geology class was a 3-day practical that we spent here in the lab at university, and that was actually pretty great to get some hands-on experiments. So we would analyze different unconsolidated sediments. For example, we would classify them using the USGS classification system to define their grain size. We would define properties of the sediments such as plasticity, for example, by applying the Atterberg limits or finding out the Atterberg limits, let's say, and also measure the water capacity of these unconsolidated sediments.
Earth management is all about recognizing, understanding and mitigating potential ecological problems, either natural or man-made ones. To do so, we look at legal frameworks, at regulations, but also at specific procedures as well as economic factors. All over the course covers a wide range of different topics, from methods of protection against geohazards, causes and countermeasures of soil erosion, disposal of hazardous substances, or landscape sculpting such as river regulation.
Before I took Earth Management, I didn't actually really know what the module was about, but it ended up being one of my favourite modules just because it's so applicable to the real world. For example, we looked at flooding in the Netherlands, and geologists, by understanding these fluvial systems, were able to really solve the problem of flooding in the Netherlands. So I really like that Earth Management gives you the knowledge to be able to solve problems in the real world.
Water is all around us. In the hydrogeology course, you will be learning all about it. This course is divided into two parts. First, we have the aqueous geochemistry. This is all about how water reacts with rocks and what minerals are dissolved in water. The second part is advanced hydrogeology. This is about groundwater systems and aquifers.